Okay, day 2 content. Here we are. Yay! We're ready to do this. So, as I'm looking through, I'm going to just kind of warn everybody that, you know, we're doing short videos and it's not going to be the entire length of a class period. I'm not going to have time to cover every kind of question that might come up in a homework set. And I feel like you guys are grad students. You can do some of this on your own. The actual history part and content part is probably a little more at an undergraduate level, so probably some stuff that you can figure out on your own. And if you're like doing homework or whatever and stuck, then feel free to contact me, especially if it's something that I didn't cover in class. But I feel like at this point in your careers, you should be able to read books and figure things out and not have to have me leading every step of the way. So don't be, you know, going nutso or whatever if you're like, oh my gosh, you didn't show us that. So the first bit, we've already talked a little bit about what's math and what are numbers. So now we're looking and we're saying, okay, number systems. And clearly I don't have enough time in here to talk us through working with every single number system that ever has been. But what I want to be able to do is talk about some of the more popular ones and some of the ones you might see in textbooks or different areas. Especially if you're planning to be a teacher, it would be nice to see some of that stuff in your future. So for instance, one of the systems that you may have heard of before, but we're not going to spend a ton of time with just because we don't have tons of time to do it, is the Mayans. Okay, so here's a picture of the Mayan system. And I think I might have mentioned the other day that the Mayans used a base 20 number system. They had an 18-month calendar with 20 days per month, and that made 365 days. So it's kind of cool whenever you look at it. They had dots that represented the first little bit of numbers, 1, 2, 3, 4, and then they had a line. And so once you had a line, that was 5. And so if you want to do anything bigger than that, you just do a 5 plus 1. That's a 6. 5 plus 2, that's a 7, and so on. So you can see how they had kind of an additive system going on. It's really kind of cool. You get to 10, that's 2 lines. You get to 15, that's 3 lines, and so on. But the interesting thing about them is they're ancient Mayans, but yet they have a cool little shell system or symbol here at the beginning. You can see it. That represents a 0. Okay. So seeing that little shell symbol representing a 0 is actually pretty advanced for an early civilization to have a very nice system of their own. So in your homework, you might have to do something where, I don't know, you add some Mayan numbers together. So let's just say, I'm going to get rid of that. If I had you working on a problem and it was add 4 plus 7, okay, that's the Mayan symbol for 4 dots. And I'm sorry, 4 plus 3. And 3 dots is the Mayan symbol for 7. Or, I'm so sorry, for 3. So I know that my total is 7, right? Whenever I put these all together. I know I'm getting to 7 somewhere. Okay. So there's my 7. But the problem with that is that they don't use 7 dots to represent the number 7, right? What do? They're using kind of a base 5 system. So once they get to a 5, they pull that out and make that into like a line, and then they would just have 2 left over, right? Okay. So instead of having it be 7 dots like this, they wouldn't do it that way. They would convert that, and they'd say pull out a group of 5. That's the line. And then put your 2 dots on the top. So that would represent their 7, right? So they would just do a little conversion. So it's actually, like I mentioned, fairly easy mathematics, easy to do because this is primitive type stuff, and that's all right. We'll get more complicated later. But you're going to see there's some addition, there's some subtraction, there's different things converting between different bases and stuff like that that you might need to do that I'm just going to kind of assume you can read and you can pick up and you can figure these things out. So I'm not going to do tons and tons and tons of stuff with that. Okay, the next system that we'll see, and I actually like this one, so it might end up as a test question. It's pretty nice and easy to deal with, is this top line up here, the Egyptians' hieroglyphics. Okay, and depending on which era you're looking at, depending on how old, who the scribe was, whatever it was, you can tell some of their symbols might look a little different. For instance, in this one right here, the symbol for 100,000 is kind of like a little tadpole, right? We see it right there. Looks kind of like a tadpole. However, on this picture that was stolen off of a wall somewhere, you can see they're trying to represent 100,000, but over here, let me get it closer, it kind of looks like a frog. So it depends a tiny bit on who the person is that's doing it. This symbol right here, that one, by the way, is called an astonished man, because he is very astonished, actually represents about the same thing as this symbol over here. But right there, he doesn't have his hands up in the air. So it might depend on the scribe. It might depend, for instance, the dialect, like if you're in different regions, that kind of thing. So the astonished man here, they even have two different symbols, right? So it just depends on the way they wrote it. I wish this particular book had the names for these things, because like this one's a lotus flower, this one they called a heel bone, I think this one was a staff, different things like that. All of the Egyptian stuff that looks like this is considered additive. So what that means is if I wanted to do 1,003,024, I would use one astonished man for 1,000,000. 3,000 would be 3 of the little lotus flowers. And then 24, I think, is the number I said. So 2 heel bones and 4 ones. So the interesting thing about them, though, so we're talking Egyptians here, is that depending on who the scribe is, they might have written it so that the bigger number is on the left, which is the way I usually write it. So here's my little astonished man. I know I'm not an artist. Okay, there we go. My astonished man. That's him. Okay, that's 1,000,000. What did I say? 3,000, so 3 lotus flowers. Of course, I picked the difficult ones for me to draw. Not an artist. The good thing is, if I'm not an artist, you don't have to be an artist either. 24, I think I said. Maybe I said 5, but whatever it was. Okay, so they might write it that way, but another scribe might write it the other direction. So they might write it with the 4 first and then the lotus flowers and so on and so forth. So it doesn't matter to them, because the truth of the matter is, if I have this astonished man here, oh Lord, goodness, help me. Okay, so if I have the astonished man, it doesn't matter if he's at the beginning or if he's at the end, his value is still worth 1,000,000. So whenever I go to do this additively, this is 1,000,000 plus 3,000 plus 20 plus 4, right? And that's working from the left to the right. But here, if I'm working left to right, it's the same thing. It's 4 plus 20 plus 3,000 plus 1,000,000. So they really didn't care which direction they wrote it. I tend to write the biggest number on the left, but they didn't really care. So you'll see that different scribes write things different ways, and it's just because it's additive, so it won't matter at all. So this particular section right here is the hieroglyphics, which is what we've probably seen in the past. We've seen a lot of stuff come up, like if you've seen the Ramses exhibit or something with mummies that's come through maybe a museum near you, then you might have seen some symbols on some of the coffins and sarcophagus and stuff like that that looked like suns or crowns or things like that. We happen to know that those symbols mean like king or God. That's what they represent. So they had pictorial things for all of their stuff, including their numbers. So even numbers had pictures attached to them. It's kind of interesting because, like I said, lotus flowers or astonished man. Maybe he's astonished because there's a million of something. I don't know. But for these things to represent stuff that they're used to seeing in their lives. So that's one. You've probably seen some stuff like that before. And then later, a little bit later in Egyptian culture, they came up with the Egyptian hieroglyphics. Okay, so you can see this it's still a little pictorial, but it's much more number based, right? You've got the 1, the 2, the 3, and so on. So it's a lot less tadpoles and astonished man looking. So that's what you'll see. So if you have to do some homework sets and they ask you, for instance, to use the Greek number system, you have to pay a little bit of attention because there's different ones depending on what time periods they're working on. So like here's Greek Ionic. That actually looks really familiar to us math people because you see an alpha in there and a beta in there and a lambda and so on and so forth. So they're just using Greek letters to represent numbers, which we're pretty comfortable with in math probably. But later on, when they get to the Herodonic stage, to me, these guys look a little more like hangmen. Okay, so they have different things that are representing different numbers, and that's not like Greek letters anymore, so it's totally different. So it really depends on what they're doing. Eventually there will be like Chinese bamboo numbers and stuff like that. So you just have to kind of be like, oh, what exactly are they wanting me to do? Another interesting one, we kind of talked about it after class on Monday, is the Roman numerals. So I'm not really big on making people memorize a lot of stuff. However, I think that most of us have seen Roman numerals before, so I think we're probably pretty good with them. So I want to just remind people what are Roman numerals and that they're out there. So any thoughts on that? Do we know any Roman numerals? The first one is like an I, and that represents a 1, yeah. So, and it's interesting that a lot of civilizations, the very first one, the 1 looks like a stick or like a finger. So it's probably related back to the fact that they were using their fingers to count 1, 2, 3. And so the very first one looks like a 1. So then there's a V, that guy represents 5, an X, that guy's 10. And most people know those 3 pretty well, and then I find that the other ones, they're like, I don't know what they are. So I'll be nice and give those to you on a test if you need them. I'll try to remember to give it to you. It's LCD, which I find funny. I call it like least common denominator. I know there's other LCDs out there, but that's the one I use in my head. In Webster brain, when I'm working on Roman numerals, I come up with least common denominator. There we go. Okay, but everything works kind of on the 5s. So there's a 1, a 5, a 10, and then the L is 5 tens, so that's a 50. The C, well, that's the next tens place value, so that's 100. And then the D is 5 of the last guy, so that's 500. And then the last one, the M, that's 1,000. And I tell people in the Roman numerals end of thing, you've probably seen it like in the preface for your book, you know, in the table of contents, they probably use lowercase I, and so on, those kinds of things. I think about maybe 3 years ago, we had Super Bowl L, and it was like the shortest one ever because it was exactly 50, right? So that was kind of cool, but now I think we're up to 53 or 54 now. But they use Roman numerals for that. I think you may have seen the M, for instance, in some old movies. Was it Universal that used Roman numerals? I think it was. But one of the old production companies used, like, I don't remember what it was, but it was Roman numerals for the year they were established, I think. So they had a 1,000 because it was 19 whatever. So they had an M in there. So it's kind of cool. The thing about Roman numerals, though, is they're not always additive. So the other number systems are a lot of additive, but Roman numerals actually, they had some rules. So they don't want to don't write more than 3 of any character in a row. 3 of one symbol in a row. Which means that if I want to write the number 3, I can write I, that's fine. No worries. And sometimes the lines mean different things. I apologize. I was raised to draw lines under my Roman numerals and above them, but sometimes an extra line means to multiply and different things, so just be aware of that. But if I want to write the number 4 in the Roman numerals, they don't want me to put 4 lines together. Instead, they want me to what? You remember?
4?
Yeah, for 4.
Like the I.
Yeah, they want me to put the smaller character before the other one. So if I put IV like that, then literally that means subtract 1 from the 5. That's literally what it means. Here, the 3 in a row that are all the same means add 1 plus 1 plus 1. Okay, this is an additive system. If I have VI, that means add 5 plus 1. And you know you're adding because the smaller character comes last. But when they move the larger or smaller character to the front, that automatically means subtract. They only do it whenever we're getting really close to the next guy, like you'll see IX means subtract 1 from 10. We know that's a 9. I'll go ahead and put my totals there. Okay, so they'll do that. But interestingly, like, let me give you one that's weird. For 49, they do not want me to do IL. Okay. Sometimes I've seen this in some people's work, but in general, they don't want me to do IL. And I think the reason for that is because there's too big of a gap. So between the L here is a 50, the I is 1, 2, 3 characters before that. And they don't like that. It's like a big jump. And the fact that we're trying to do something that takes up 2 place values. So actually the Romans normally, what you'll see in most texts, is that they want you to do a 40 and they want you to do a 9. Okay, instead of doing take 1 away from 50, they don't want you to do it that way, is what I've normally seen in most of the texts that I've done. So the 40 will actually require me to do some adjustments anyway, because whenever I look at it, I've got X, 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 X. Well, they don't want me to do X, 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 right? Because that's 4 of them. So how can I do 40? I can take the 50 and subtract off a 10, right? An X. So if I take 10 away from the L, well, that's okay because that's only 1 character before the L, right? It's really close. And if I want to do 9, well, then I can do what we did a second ago up here. I can do 1 from the X. And that's okay because it's only 2 characters away from the X. But they don't want me to do more than that in general, is what you'll see. So I think it has more to do with the fact that these are 40 items and it's place values, and these are 9 items. And for some reason, whenever the Romans looked at this, they went, oh, no, you can't take a single place value, a 1's, away from a 10's group. So it's kind of interesting the way that that works out. So anyway, those are Roman numerals. They're out there. If you see them, if they come up on homework, then don't be surprised by it. It all works out in the end, I promise. All right, so what are we going to worry about? We are going to worry about, because that's all the time I'm spending on any of those. Okay, so if you run into problems with those and you're not sure, feel free to ask me questions or try to get with me in office hours or try to get me to meet you on Skype or something like that. But other than that, I feel like y'all can do that on your own. So we're going to worry about Babylonians. Okay, and I think I mentioned the other day, they were around approximately 5,000 to 3,000 BC. It's around 3,000 BC that we start seeing seeing that they're writing things, that they've got a number system. These guys are in Mesopotamia. Okay, and I happen to bring my lovely world map with me tonight. So I will load a blank of the lovely world map onto D2L so that you can print your own and follow along if you would like to. It'll be great. So here is my lovely world map. Ooh, I need to make it darker is what I need to do. Let me zoom in on it a little bit. All right. So these guys are in Mesopotamia, and Mesopotamia, I think it literally means the land between the rivers. Okay, so in here we've got the Arabian Peninsula. We're looking at the Middle East. Asia's over here, Europe's over here. Inside of here, there are two rivers coming down. And they start out wide and kind of come together. And these are the Tigris and Euphrates rivers. I think we mentioned those the other day. And in between there is the land between the rivers. And it's a very fertile area, and this is where the Babylonians are going to be. I'm going to put a B for Babylonians. Some point I'll try to get a map loaded up that kind of has a key to it so that everybody has access to it. But in the meantime, just think to yourself, okay, Middle Eastern, the area would be Persia or Mesopotamia, or probably about where we would see modern-day Iraq, okay, is about where we're thinking for Babylonians whenever you see them. So they're in that area. Zoom back out, zoom back out. You can do it, little thing. No, it's not going to focus. Oh, it did focus. Yay. Okay. Yeah. There we go. Perfect. Okay. Mesopotamia, they're somewhere around Iraq. They're in a river valley. Yay. They have a cuneiform system, which I'm pretty sure just means like cune means like wedge, basically. So basically, they're using clay tablets and a stylus. And the stylus would look like a wedge or a golf tee or something. It would kind of be like I can hold it and it makes this kind of a mark because it's triangular in the base. So I can drag it down and I can make a 1. Is the way that it would work out. And so that was one of the symbols that the Babylonians had, was just take your stylus and just drag it straight down. That makes a 1. Well, if you can imagine, I'm using wet clay and I've got a stylus and I'm trying to make things. There's not a ton of stuff I can do with that's, other than make a bunch of 1s or whatever. So they actually only have 2 symbols. The other one is a sideways guy and then another sideways guy. So I kind of call these the Pac-Man. They look a little bit like Pac-Man to me. That one represents 10 of something. So I have a symbol for the Babylonians that represents a 1 and a symbol for them that represents a 10. That's starting around 3000 BC. Later, probably around 300 BC. And depending on the area that you're looking at, the region, they actually add a symbol, one more symbol. Either it's 2 triangles on top of each other, depending on where you are, or you might see it as 2 triangles, two slashy marks that are kind of sideways and side by side. So they're either on top of each other, these 2 triangles, or they're side by side. Either way, that represents 0. And it's a placeholder. So eventually they come up with, hey, some of these numbers are hard for us to read. Maybe we ought to come up with something to kind of represent, hey, there's nothing there right now, don't worry about it. So later we have that guy that comes in, but most of the time you just got the 1 and the 10, which is kind of interesting. So that's not too bad, because if I have, say, I want to say 35 of something, that's not terrible, right? And I'm going to be really lazy, and if I'm really lazy, you're allowed to be really lazy. So I'm immediately going to shorten this. I'll probably never draw another Pac-Man like this again. So the up and down wedge thing here, it's going to look like a stick, like in the Egyptians or different places like our number 1. And then this guy is going to kind of look like an angle symbol or a less than sign. So that's what I'm going to do. So I don't have to draw them all out all the time because I'm a bad artist. So I need 30. So I need what? 3 of the Pac-Mans, right? 3 less than signs or angle signs or however you want to think about that. And then I need 5. So I need 5 of these sticks or units or ones, however you want to think about them. So that's not terrible because, okay, it's 35. No worries. But the problem becomes, well, what about if I want to say something like 95? 95. Okay, now 95 is interesting because 35 was less than 60, and if you remember, we talked about the other day, the Babylonians are in a base 60 world, right? They did 2 lunar cycles is what we think for harvest seasons and stuff like that. So they're in a base 60 world, and 35 is less than base 60, so that one's not a problem, but 95 is bigger. So in my world, what I do is I lay out place values for them, okay? And I say, okay, if you don't remember, by the way, how to change back and forth between bases, to go from base 10 to base 60 or back and forth, then spend a little time, let me know, but I'm not going to spend tons and tons of time in this class with that. But what we're going to say is, look, I got one group of 60s inside there, so I can pull out the 60, and whenever I'm done, I'll have 35 left over, right? So in base 60 world, that's a 1, 35, and we write that little subscript base 60 that lets everybody know this is not a base 10 number, this is a base 60 number. So if you don't remember that stuff, go back and look at it, watch a video, come see me, whatever you need to do. Okay, so that would be in our Arabic numbers, right? The numbers that we usually write, Hindu Arabic. But that's not Babylonian cuneiform. So if I want to change that into Babylonian cuneiform, I would draw just the 1 for this guy, and then I would draw the 35, which we already made. So that's not bad. Okay, so that's not terrible. We can make it work. It's all good. But then the problem comes in, what if I had, instead of that one, what if I had 635? So again, kind of think place value wise. The bigger place value above this, by the way, would be 60 groups of 60, which would be 3,600. I don't need that place because this is not that big. But if you needed to convert bigger numbers, you would need a third place value. So just be aware that's out there and remind yourself how bases work. Okay, but here I'm looking at it and I go, hey, wait a minute. 60, I got 635. If I divide 635 by 60, I'll get a 10. So there are 10 groups of 60 in there. Okay. And then I've got the leftover 35, no problem, right? But the problem with that is whenever I go to do this in cuneiform, if I do the 10 like that, and then I have the 35, now we might have a problem with interpretations. And it kind of depends on who the scribe was that was making up the clay tablet, right? Because if I kind of give a little bit of a gap there, like I just did, maybe you might think, oh, that guy is not really butted up against these 3 Pac-Mans, so maybe this is a different guy. Okay, maybe that represents 10 groups of 60s. But if I don't give you that, or if I'm a lazy scribe, and I do something like that, and you're like, yeah, that looks like 4 10s, right? That looks like 45 instead. So the question becomes, how do I know? How do I interpret this? When we're trying to transcribe stuff that's in clay tablets thousands of years later, how do we get there? Eventually, they might put that little triangle thing there, which represents, hey, This really is in the 60s place, and there aren't any ones in that, okay? So you really do have 10 groups of 60, but sometimes they don't do that. So there are errors in some of the transcriptions, in some of the places where they're trying to decipher some of the Babylonian stuff, and part of the problem is it's lost in translation because of not having good spacing, not having good notation, that kind of stuff. So you have to just kind of be aware that that's out there, and for anything that I would give you, it would be very obvious, but for other people, it might be a problem. So, and especially as we start talking about transcriptions, that's where the errors come in, something like that. It's just hard to read, basically. Okay, so here we go. Who did work with these? In your PowerPoint that I've loaded up, there's a lot of stuff in there that talks to you about different ones. I just want to talk to you about two. So this guy's name is George Friedrich Grotefend, Grotefend, and I'm pretty sure he was German. I'm not certain of that. His dates are 1775 to 1853. Now, you're not going to have to regurgitate back to me dates. I don't really care about dates, except just as a point of reference. So my point of reference here is that we're looking at Babylonian tablets that date back to about 3000 BC. And this guy doesn't come along and start actually working until about 1800 AD. So, you're talking close to 5,000 years difference, right? So anything that's in the Babylonian tablets, whenever they were written 3000 BC, it's over 4,000 years old. And there's not a lot of people in the 1700s and 1800s who speak Babylonian, okay, who write Babylonian. So this is actually a really in-depth task for this guy to undertake. So he's trying to make transcriptions. There were a lot of errors, and he actually had some criticism about that. But he did decipher a lot of cuneiform. In particular, that's what he was looking at, was the cuneiform, the Babylonian stuff. So kudos for his effort, even with making some errors. And some of the errors are things like what we talked about a second ago, where it's just hard to read, or maybe one scribe writes something a little bit differently. Some scribes you'll start seeing, if they wanted to do 30 of something like this, they might like interlink the thing. So they might say, hey, let's make them 3 chevrons or 3 angles that are kind of touching each other, so that we know those 30 all go together. So some people tried to do something to make it easier, but not everybody. So that guy's out there. Yeah, and look at that, 1853. I mean, I know we're in 2020 here, but that's not that long ago, really. It's a couple of hundred years. Whenever we're talking thousands, that's pretty recent, so not too bad. The other guy is Henry Creswick, Creswicke, Creswick Rawlinson. And there are some pictures of some of these guys in the PowerPoint that you'll see. His dates are 1810 to 1895. Okay. He was an officer in the Indian Army, and what he did was actually there still are cuneiform stuff and Egyptian stuff and different things on a wall. So it's actually a pretty famous wall in the Middle East. And he took some rubbings of them, and he did translations. So he actually worked on 3 different languages that were all cuneiform. One was the Babylonians. So lots of early civilizations that were using wedges and clay tablets to try to communicate with the rest of the world. So the Babylonian thing is called Akkadian, so just so that you're aware of that. All right. So that's the biggest part of the stuff about the Babylonians I want to talk about. we'll pick up as we go into Egyptians. There will be a tiny little bit about the Rosetta Stone. So maybe, I don't think we'll get to that tonight, but the Rosetta Stone is actually going to be, you've heard of the Rosetta Stone, the language company, right? So they call themselves the key to unlocking languages or something like that. And in the math world, the Rosetta Stone is an actual tablet, and it's a stone, and it's a clay tablet with markings on it, so you know it goes back to the Babylonians. But the interesting thing is that it actually was written, the same stuff was written in Babylonian, in Greek, and in Egyptian. So that's actually how we know what we know, because the fact that it was written in Greek, the person who transcribed it could read the Greek. So then when they realized, oh, this other stuff is the same, but it's in a different language, then he could unlock the hieroglyphics. Then he could unlock some of the Babylonian stuff. So it's kind of cool because that's how he had the key, was because one of the languages he spoke. So he was okay with that. Interesting. So that's going to come up, and it'll tie the Egyptians and the Babylonians together for us, which is kind of neat. So the next, I know, take a breath. Whew. We got a little bit of time. We got to do a little bit more. The next civilization is the Egyptians. So I do want to get them in here. We won't finish them tonight, but we'll get them started. And next time we'll work like an Egyptian. Not walk like an Egyptian, but work like an Egyptian. It'll be fun. Okay, so we'll get to do some math the way that they did their math. So it's awesome. So Egyptians, bring out the map again. We know that Egypt is here in Africa. We know that the Nile River kind of comes down the edge here. And Egypt is actually a country way up here at the top. At the time that we're talking about, Egypt probably actually covered a huge chunk of this area here. I'm going to give it an E for Egypt. Okay, but it was definitely the civilization that settled around the Nile River there. So we see it there in Africa. So here's Egypt, here's Babylonia. The only thing separating it is this little Arabian Peninsula, which is really big, but you can see how they would be able to share some knowledge and maybe use the Mediterranean and some different riverways, waterways to get to each other. So we can definitely tell that they had interaction even though they weren't side by side. So Egyptians and Babylonians. So there's our Egyptians. Egyptians don't use clay tablets. Do you know what Egyptians use? Put you on the spot.
No.
No, dang it. I don't know what they use. Don't put me on the spot. Instead, they use papyrus. Okay. And probably people have at least heard the word papyrus before. It's kind of like a very, very early form of paper. So what they did was they had reeds and bamboo sticks, that kind of thing. And they would slice them open and they would flatten them. And it would make like a strip. Because think about it, a bamboo is not very big, right? So maybe you have a 3-inch wide strip or something like that if you have a really tall, big, thick bamboo. And so they would take that and they would flatten it and they would dry it. And then they would do another one, another strip, another bamboo, another reed, whatever they had. And they would dry it and they'd try to make them about the same length, but it never ends up looking the same length. And they would actually glue them together using kind of a plant-based glue. And if I get enough of these strips together side by side like this, like my lovely picture is showing us, and I can glue them together and then have that dry so that it's all flat and it's all one big thing, it kind of starts to form a piece of paper, or more likely they made scrolls out of them. So really long, wide pieces of paper that they could write in. And actually, I think I have a picture of that. So let me look for that while I'm thinking about it. But then they would be able to actually write on it, so they didn't have to use a stylus like the Babylonians did. So it wasn't as poorly put together and difficult. So they didn't have quite, there's one, they didn't have quite as bad of a notation problem as the Babylonians did, because they had more ability to write and just kind of use probably berries and stuff like that for ink. So this is actually a picture of the Rhind Papyrus, which is a really famous one. But you can tell here, look, there's a strip and it's only so wide, and then there's more strips, and they've kind of just stuck them all together. It looks all frayed and tattered at the top and that kind of thing. The thing about papyrus is it's going to be very brittle. So I can write on it, but it's going to end up being super brittle. And if I'm using it like a scroll, if it's really long and wide, and then I try to roll it up, it might break off. So you can see like missing sections here, and this piece is gone. So it's very easy to actually lose stuff that's on papyrus, and it's flammable, right? Because it's plant-based, so you can burn it. So not that we would want to, but sometimes people did. So things happened. Okay. So the Egyptians, they're using papyrus, they're using hieroglyphics, which is normally pictorial. Later that turns into hieratics, which is a little less pictorial. And then later, oh goodness, it's called demotic, I believe. D-E-M-O-T-I-C, I'm pretty sure. I don't have it written down, but I'm pretty sure that's the third version of Egyptian numbers is demotic, I'm pretty sure. So anyway, you've got these three different things, and they're written on papyrus, and nobody really knows a ton about them until around 1798. Napoleon invaded Egypt. So some of these papyrus have been around, like I say, for thousands of years by this point in time. But Napoleon invaded. And if you know anything about just our history in general, you know, a lot of times war is when things happen, when cultures exchange knowledge and things like that. This is the same thing. Napoleon is just trying to conquer the world. So he invades Egypt. However, he doesn't have any intention of staying in Egypt. So when he comes, he's like, oh, I'm going to bring a group of people who can occupy. Okay, so he leaves behind people that he called scholars. And he thought, for him, he thought that these scholars were going to be occupying in his name and you know, making a name for the French and yada, 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 and taking over. And instead, he kind of miscalculated, because they were actually scholars, and they actually were interested in what was going on there in Egypt. And so they actually started studying. Like, they're like, we don't care about occupying for France. We want to study. So they actually started studying the hieroglyphics, and that's when some information starts getting out that's kind of cool. So we get to do all that. One of the people his name was Jean-Francois Champollion. Jean, Jean-Francois Champollion. So Champolilion. And his dates are 1790 to 1832. Okay. So he was actually a scholar. He actually cared about what was going on. And he was interesting because he actually studied the Rosetta Stone. So let me get a picture of the Rosetta Stone up here so we can see it. Got it somewhere. I had it just a minute ago. Here it is. So he was interested in the Rosetta Stone. And this is the one I mentioned earlier. It's kind of like I think it's black. basalt, is that the right word? I don't remember. Anyway, the stone, it's actually Rosetta Stone, but you can tell if you look really closely, it's like in 3 different sections. Here's one that's a little more hieroglyphic. It's more of the Egyptian thing. Here's one, and here's one down at the bottom. So one of those, I think it was the bottom one, was Greek, and he could figure out what was going on with that. The other one, the hieroglyphics, was like how really ancient Egyptian, and the one in the middle is the Demotic, which is kind of the latest, the most recent Egyptian writings. So they're less, you can tell just looking at that picture, they're less pictorial and more actual writing. So he was able to kind of say, okay, this Greek thing is like this other Demotic thing, and that thing's more like the hieroglyphics, and unlock stuff that way. So he's kind of a cool dude. Again, you're not going to have to memorize dates or anything. I just want you to know who's out there and who did what. Okay, so the Rhind Papyrus, which I showed you a picture of a minute ago. And I'm just going to tell you a tiny bit about it, and then we will be done for the day because I'm running out of time quickly. Okay, the Rhind Papyrus was actually named after a guy named Henry Rhind, R-H-I-N-D. His dates are 1833 to 1863. And if you think about that, 1833 to 1863, that's actually a really short time period. It's only 30 years. We live longer than that nowadays for sure, but even back then in the 1800s, people should have been living longer than 30 years. So the thing about him is he's a Scottish guy and he has tuberculosis. So when he was young, like in his early to mid-20s, he decides that what he's going to do is he's going to leave the United Kingdom, where Scotland is, and he's going to come down into Egypt because he thinks that the air there will be good for his lungs. Okay, I think he actually ended up having more problems because there was sand in the air. So, but he thought it's dry there, I'm not going to have the humidity, it will be better for my lungs. So he went there. He didn't stay for very long. He actually ends up moving back to the United Kingdom, actually part of the time back to England. But the cool thing is, while he's there, he happens to be, the story says, he was in Luxor. It was 1858. You'll notice I have to look for the dates, so I don't expect you to memorize the dates. So I don't memorize them. Okay, so in Luxor in 1858, the story is that he was in a flea market. And he found the Rhind Papyrus. That's what they say, at least. So we'll go with it. That's the old story. Okay, so it's interesting because nowadays, I mean, we're talking 1800s, right? So nowadays, that would be considered a priceless artifact of Egypt, and there's no way that they would let it be sold in a flea market. And if anybody were to purchase it in a flea market, the Egyptian government would be fighting to get it back, right? But back then, apparently, you know, people robbed tombs or whatever, and they found ancient things, and they're like, yeah, let's just sell it. Maybe I can get a few bucks for it. So this guy apparently saw it and recognized it as something of value, and he purchased it, and he brought it back to the British Museum. And that is actually really cool for us because people in the British Museum are going to study it. There's going to be some translations of it, like several translations of it. One guy, Arnold Chase, C-H-A-C-E, his dates, let me find them real fast, 1845 to 1932. He's going to spend a ton of time with that Rhind Papyrus, and actually in 1927 and then again in 1929 he's going to write some translations of it that are really going to open up a lot of information to us because the cool thing about this Rhind Papyrus is what we find out. It's basically like an ancient math textbook that you would give to somebody that was trying to learn their numbers, trying to learn about fractions, trying to learn about geometry. There's a lot of exercises and problems in there on the Rhind Papyrus. And so what we're going to do next week is we're going to actually open up some time and spend, like I said, working like an Egyptian. We're going to work like an Egyptian. And we're going to do some multiplication. We're going to talk about the way they attacked fractions, which is to say that they didn't want anything that wasn't a unit fraction. If you're not sure what a unit fraction is, go look it up before next week. We'll talk about it on not Monday, because Monday's a holiday. We'll talk about it on Wednesday. And we'll talk about how the Egyptians would decompose a fraction into unit fractions. And then we'll talk about some more modern ways that people use to decompose fractions, which is really, really pretty cool, because it's all spurred on by this ancient papyrus that's like thousands of years old. So that's my game plan. That gets us into the Egyptians. So that's our second civilization, and we'll pick up more on that next week. I hope everybody has a lovely weekend. All right.